Okay, so we are going to look at the variation of the daily, of the variation in daily and atmospheric temperature. Now, what you have to know is that the temperature during day, it is not the same temperature during night. Do you agree with that?
Yes.
The temperature during day is not the same temperature during night. So what do we know? At night, if someone tells you that I'm sweating at night, you may think that something has a problem with the head, or someone is from running or what. If you are sweating at night, maybe you are sick, isn't it? If you start sweating. But I know, Sean,
Yes, teacher.
most of you eat a lot and then you start sweating at night, isn't it? So that kind of sweating is due to maybe the body system, but that the temperature of the day is so different, very different from the temperature during night. In other words, they're saying that during night it is colder. Have you ever wondered why it is colder during night than during day? And they are saying that there is that temperature change whereby at night it may be around maybe 20 degrees Celsius, and during day it may be around maybe 25 degrees Celsius or 18 degrees Celsius during day. So that change in the temperature is what we call the diurnal. How do you pronounce this? How do we pronounce that?
Diurnal change.
The what? Diurnal change, isn't it?
Diurnal change.
Diurnal change. So we don't need a linguistic here, but it's called diurnal change, isn't it? So what is diurnal change? Diurnal change is the difference between the temperature of the day and that of night. So you write that diurnal change is the difference. Hello. Okay, members. So we have that diurnal change. Diurnal change is the difference between the temperature of the night and that of during day. So the change in temperature from day to night is brought about by one. What causes the change in temperature? What causes the change in temperature? So that's the question. What causes the diurnal what? Diurnal change. What was diurnal change? Oh, the change in what? In temperature. What causes diurnal change? Sean is what? What causes what?
Diurnal change.
What causes diurnal change? One is the rotation of the what? Is the rotation of the earth. The rotation of the earth rotation, the daily rotation of the earth. So we call it the rotation of the earth. Rotation of the earth. And we are going to explain this. One is the rotation of the earth. So they are saying that as the earth rotates, the land or the earth receives the heat during the day from the solar radiations from the sun. And this continuously hits the earth's surface. So this warming that happens during day depends on the imbalance of the solar and the surface radiation. So during day, the solar radiation, what do you mean by the solar radiation? The heat from the sun. During day, the heat from the sun or the solar radiation exceeds the surface radiation and the surface becomes warmer. Now, what you should know is this, that even the surface itself, it radiates when it receives the heat. When it receives the heat from the sun, it radiates. But because during day, as time keeps on going from morning up to maybe in the afternoon, there will be an imbalance in the solar radiation. The radiation from the earth tends to be lower than the radiation from the what? From the sun. So during day, maybe in the afternoon there, you find that the earth, its radiation is far low compared to the radiation from the sun, meaning that now it is the sun which is exceeding a certain radiation from the earth. So the sun will be hitting the what? Will be hitting the earth. So as time goes on, maybe in the evening there, in the evening, when the sun has gone maybe to sunset, the radiation from the sun reduces. And then the radiation from the earth exceeds that one from the what? From the sun. So now the earth continues to radiate, meaning that its radiation exceeds the one of the earth, of the sun. Why? Because the sun has gone to sunset. Then during night, it is worse. During night, it will be very worse because there will be no sun. So it means that during night, the heat from the earth will be lost to the atmosphere, and the earth will feel colder. Why does it feel colder? Because the earth has lost all the heat to the atmosphere. So this causes the temperature during night to be low compared to the temperatures during what? During day. So during day, the earth becomes warmer. Why does it become warmer? Due to the solar radiation it receives from the what? From the sun. The solar radiation that it receives from the sun. And during day, you have to know that that solar radiation exceeds the surface radiation or becomes greater than the radiation from the earth. I've told you that also the earth radiates heat. How does it radiate heat? When it receives the heat from the sun. Okay. So you have to know that the first thing you have to know that during day, okay, we can say that the earth receives heat during day from the solar radiation, and this continuously hits the earth's surface. So that is the most important thing for you to know. Where does the earth gain heat from? The earth gains heat from the sun. And the earth becomes warmer during day. So we can say that as the sun hits the earth, as the earth as the sun hits the earth, comma, the surface of the earth gains heat and becomes what? And becomes warmer. During what? During day. During day, the earth becomes warmer. But you know that the earth, once it gains heat, it starts to radiate that heat. It starts to lose the heat. That's why if you are on a tarmac road, if you are walking on a tarmac road, and you put your fingers or you put your hand on a tarmac road, you feel when that tarmac road is very hot. Why? Because that tarmac road has gained heat from the sun and it is now radiating that what? That heat. So the other thing you should know is that the surface of the earth continuously loses heat by the surface radiation. So the earth's surface continuously loses heat by the surface what? Radiation. Okay, so the first chapter we have seen that it is the sun that hits the earth and the earth gains heat and becomes warmer. But you should know that once that earth's surface becomes warmer, it continuously loses the heat by the surface radiation. You see when the surface of the earth is losing heat, that tarmac road, for example, would be hot, meaning that it is losing what? It is losing heat. But the rate at which the tarmac road gains heat is far low than the rate at which the sun is emitting its heat. So it means that the radiation from the sun is far greater than the radiation from the earth. So it means that the solar radiation, what is the solar radiation? So during the solar radiation exceeds the surface radiation. This one means that the heat from the sun exceeds the heat from the surface of the earth during day. And that is true. The heat from the sun cannot be compared to just the heat from the what? From the earth or from the tarmac road. So this is true that during the heat from the so we can say that during day no, not during day, we say that the solar radiation and this solar radiation is the heat from where? From the sun. In brackets, heat from where? Heat from the sun exceeds the earth, the surface radiation. And the surface radiation is the heat from the what? Heat from the earth is what? Earth is surface. What causes that change? Diurnal change. What causes diurnal change? What causes diurnal change? What causes diurnal change is the rotation of the earth. So if the earth is rotating, it means that the earth's surface will be heated by the heat from the sun. The earth surface becomes warmer during day and it starts to radiate the heat. That radiation is what we call the surface radiation, the radiation from the earth. But you should know that the heat from the sun, which is also known as the solar radiation, for it is far, far greater than the heat from the earth's the heat from the earth's surface. So this makes the surface of the earth to continuously become warmer and warmer. And during the day, you have high temperatures. High temperatures. So the earth's surface becomes warmer and warmer during day. How about during night? So at night, when the sun has disappeared, it means that the land stops receiving the heat from the sun. So now the land or the surface of the earth continues to lose the heat to the surrounding, or continues to lose the heat through surface radiation. Surface radiation, that process by which the heat is lost from the surface of the land. So during night, the sun disappears, and now the earth radiates the heat or loses the heat through surface radiation. As the land continues to lose the heat through surface radiation, it becomes colder and colder, therefore reducing, or therefore a decrease in the temperature during what? During night. Are we together? Are we together? Sean, are we together? And the Infinix,
Yes,
Infinix Hot 9. Huh? Who's called Infinix Hot 9?
Yes.
Hey, put your name, please. Infinix 49. Put your name. What's your name, Infinix 49? So you should know that the earth hits the surface. So let us say at night, comma, at night, the surface of the earth, the surface of the earth loses heat through surface what? Through surface radiation. Full stop. Through surface radiation. Okay, let us continue. And this cools the surface, and that cools the surface. So the surface of the earth cools down because the land continues to lose the heat. So they are saying that this cooling continues even after sunrise until the solar radiation.
Papa is learning.
So the cooling continues, until the solar radiation exceeds the surface what? Exceeds the surface what? The surface radiation. That's why some days you may see the sun, it is there, but it is cold. Not because maybe it is raining, especially during morning hours. The sun is there during morning hours, but it feels what? Cold. Why? Because the solar radiation has not exceeded the surface what? The surface radiation. And that kind of radiation is what we call that terrestrial radiation. The minimum temperature, they are saying that The minimum temperature usually occurs after sunrise, sometimes as much as 1 hour after, and the continued cooling after sunrise is the reason why fog sometimes forms shortly after the sun is above the horizon. So even morning hours, the day will be cold. Why? Because the solar radiation has not exceeded the surface radiation or the terrestrial radiation. And it means that the morning hours are going to be cold. And this leads to the formation of dew. Now, for us, we don't have fog, but we have mist or we have dew. But fog is some kind of mist, mist. But this mist is of let me say of large quantities. Should I say like that? But you should know that fog is normally in those countries that normally have winter, what and what, those countries. But here in Uganda, we get mist or dew. So mist or dew, you see it at night. I mean, in the morning. In the morning, when the temperatures are still low. Why are temperatures low? Even if the sun is there, it is because the heat from the sun has not exceeded the heat that the surface of the earth radiates. Okay. So this means that the heat from the sun is not of more value to heat up the land. So the land is still very, very cold. It is still very, very cold. And when the land is still very cold, it means that even the surrounding, anything surrounding that land will be very what? Will be very cold. And this leads to the formation of dew or to the formation of mist. Now, mist is formed because the land is very cold. The air droplets are going to condense, and those air droplets are the ones that form dew or are the ones that form mist or fog. Why? Because the land is very cold. Do you have any question before we go to atmospheric temperature? We have finished the one of rotation of the earth. So we are going to look at the atmospheric temperature. Any question? Kathy? Hope? Hope, I think this is my first time to see Hope. Hope, how are you?
Hi.
Okay, I'm seeing Hope. There is is this Hope Elizabeth? Yes. And Ruben. Is this Ruben? Ruben.
Yes.
Ruben, which class are you?
Senior 1 North.
Hey, I think this is also the first time to see Ruben. Hey, you are welcome. So we have been studying. Okay. So let us look at atmospheric temperature. Atmospheric temperature. Okay, so just know that we have moved ahead. So we are going to look at atmospheric temperature. Then in the next session, we shall look at, we are going to start maybe heat transfers. Okay. So atmospheric temperature is the measure of the temperature at different levels of the Earth's atmosphere. Atmospheric temperature. Now, in geography, you have seen maps. Maps, there are some regions. Maybe let me see on Google. Let us first write the definition. Atmospheric temperature is the measure of temperature at different levels of the Earth's atmosphere. Is the measure of temperature at different levels of the Earth's atmosphere. So you should know that the atmosphere of the Earth, let me see here, and you can see this from Google. Okay, some of you are still copying the notes. Put this one here. Let's see. Okay, let's put here Earth's atmosphere. You're going to see that the Earth's atmosphere has got very many layers. Very many layers. Pictures. Okay. This atmosphere. Okay. Let's see here. Okay, let me see ore and I see. This one. Okay. So the atmosphere of the Earth, maybe this can help us understand what we want. So the atmosphere of the Earth has got different layers and different layers and different layers. Where's it going? Okay, can see. We have this diagram. I hope you can see it. I will maximize if I need you to see it like this. So it has got different layers. This is the Earth's atmosphere here. This one here. Okay. It is called that we have the troposphere. We have stratosphere, mesosphere, thermosphere, and exosphere. So the Earth's atmosphere is just this one here. This one where you are seeing clouds, that is the Earth's atmosphere. This one here where you're seeing clouds. So this Earth's atmosphere has got different temperatures. Maybe if you may see this one here, there are different temperatures along that atmosphere. So the measurement of atmospheric temperature, the measurement of the temperature at different levels of the Earth's atmosphere is what we call the atmospheric temperature. So what causes this atmospheric temperature? So there are many factors, but one of them includes the solar radiation. When they say solar radiation, they are talking about the heat from the sun. The heat from the sun contributes to different levels having different temperatures within the atmosphere of the Earth. So we have the solar radiation. They have chemistry, not now. Later. There is also humidity. Humidity is also another factor that determines the temperature in the atmosphere. Then also the altitude. The altitude. So the altitude, you know what altitude is. The altitude. So that's vertical distance or the height above the Earth's surface. The altitude. So there are some areas or regions that have a high altitude and other regions have a low altitude. So you find that some regions that have a high altitude, maybe their temperature is low compared to the regions that have a low altitude. So even with the atmosphere, as you move away from the Earth, we have different levels of the atmosphere. Some of them are next to the Earth, others are far away from the what? From the Earth. The same way how you have seen in this that some of them are next to the earth, others are far away from the what? From the earth. So it means that those ones that are far away from the earth have low temperatures compared to those which are near to the what? To the earth. Why are the ones near to the earth having high temperatures compared to those that are far away from the earth? Is because the earth also radiates heat. The earth radiates heat from the radiates heat, but this heat, it gains it from the what? From the sun during day. So as the sun hits the earth during day, the earth gains the heat, and then the earth starts to radiate the heat. So those layers of the atmosphere that are near to the earth, they become warmer compared to those layers of atmosphere that are far away from the what? From the earth. Okay, I think I've understood that. So the amount of solar energy received by any region varies with seasons or altitude and time of day. These differences in solar energy create temperature variation. So we have different seasons, and you may agree, if I've ever been out during winter, it is not something of a joke. It is really very cold. If I've ever been in, let's say, in Libya, where it is very hot, it's not something of a joke. So may you want to move even when you are, when you are what? You have no clothes, like Adam, in Adam's suit. So it means that the temperature there is very high. Why? Because of, normally because of different seasons. So even here in Uganda, we have different seasons. There's sometimes when it is very hot, and sometimes it is very what? It is very cold. Now you wait in November, it's going to be very cold. But as maybe as you move away to January, then it may be very what? Very hot. So the seasons cause also a variation in the temperature levels within the atmosphere above the Earth's surface. Are we together? Then the other thing is that temperatures also vary with the differences. We are going to write notes, but I want you to understand temperatures also vary with the differences in relief and altitude. What is relief and what is altitude? Let me ask you, what is relief? What's relief? Who knows what relief is? Who knows what relief is? So relief is just like the physical features that are on the Earth's surface. The mountains, the valleys, the lakes, the what, the forest, what and what. That is relief. Okay. So mountains. Now you have seen some mountains have a low temperature. For example, I can give you an example. Those people come from where? From Umbari. They're always suffering from what? Mudslide. Those people come from Renzori. The relief there. The relief contributes to a difference in temperatures on the earth, also to the temperatures in the atmosphere. And the altitude also, it is the same thing, that regions that have a high altitude have low temperatures, and regions that have a low altitude have a high temperature. So at a high altitude, don't expect to have maybe someone sweating there or what, no, because there the temperatures are very, very low. They are very, very low. If you have ever been in Kasese, you will be my witness. Okay. So in the next session, when we come back, we are going to write the notes about atmospheric temperature, and then we continue and we look at the heat transfers. But there is an activity here that I'm going to leave you with when you come back. So in just seconds, you can have a break and take some water. Then once the lesson resumes again in just a minute, then you come back.